Hello, boys and girls. I just wanted to make a video, a hint video for the mid-unit check that you'll do while I'm at central office. And well, for three classes, I'll be at central office. For two classes, I'll actually be in the classroom. So make sure you put your name on it. So I'm going to do that, of course. So I'm Mr. Rowe. Date for most of you will be 9/23/21, but for one group will be 9/24. And period is simply your math class. So either math 2, 3, 5, 6, or 7. And it says create the area of calculate the area of polygons C and D. Show your reasoning. And D is just a triangle. So I'm going to rotate around and identify the base and the height. C, I really can't cut into a rectangle, square, or parallelogram. Therefore, I'm going to create it into two triangles. So I'm going to draw a line here. And effectively, this becomes the base of one triangle. This is the base of the other triangle. And the height of the triangles are exactly the same because they form 90-degree angles. So the base of this triangle is 2, and the height is 1, 2, 3, 4. So I have one 2x4 triangle, and I have one 1, 2, 3, 4. So that's a 4x4, and I have one 4x4 triangle. Now all I have to do is apply the triangle formula. Hi. And so you could take 1/2 the base or 1/2 the height, which is what I would do. So I would just simply take 1/2 of 2, which is 1, so 1 times 4, so that's one area. And then the other triangle, I would do the same. I'd take 1/2 of 4, which is 2, 2 times 4 is 8, and then I would add those together. And that would take care of C. D, I would use this as the base, the 3. And the height I'd measure on the outside, starting here, all the way to here. Notice I formed a right angle with that. So it's 1, 2, 3, 4, 5. It's a 3x5 triangle. And of course, it's base times height divided by 2. Base times height divided by 2. Calculate the area of polygons D and A and highlight the base and height you used. Well, the base on this parallelogram, I'm going to use this. So I'm going to use the 5.5. And the height, I'm going to use the only line that I identified as a right connected to the base with a right angle, 90-degree angle, and that says 6 inches. So it's a 5.5 times 6. And that would be the area of the parallelogram. Now, you might want to break this up. You might not remember or recall how to multiply decimals. So you might want to call this 5 times 6, and then 5 times 1/2. Of course, 5 times 6, basic math fact, 5 times 1/2 is just 5 halves. Well, 5 halves is 2.5. 2.5. And then you would add those together. Okay, the next one is a simple triangle. The base is the 5 inches. The height is the 12 inches, because I know that because the base is connected to the height through the right angle connection. You also technically could use 12 inches as the base and 5 as the height, but it doesn't really matter because all you're doing is multiplying them together, correct? So here, again, I could apply the triangle formula, which is base times height divided by 2, or I could simply take 1/2 of one of these numbers, which is what I would do. I would just take 1/2 of 12. So 1/2 of 12 is 6. So the area of this triangle is 6 times 5, which, by the way, you'll get the same answer if you took base times height divided by 2, right? 12 times 5 divided by 2 is going to end up being 6 times 5 as well. Calculate the area of each polygon. So this one, I would simply make into a big square. Big square. The Kevin method, right? That's the Kevin method. So it's 10 by 10, right? So the area of a 10 by 10 square, obviously, is 100 centimeters squared. and then I would calculate the area of this piece right here. Well, the distance from here to here must be 4, because 10 minus 6 is 4. And the distance from here to here must be 3, because 10 minus 7 is 3. So we have here a 3 by 4 triangle that I need to subtract from the 100. Of course, the area of a 3 by 4 triangle is simply base times height divided by 2, or again, take half of the height or half of the base. I'm going to take half of 4. So it would be just simply 2 times 3. And then I would subtract that away. Next shape looks like an arrow, almost like a traffic arrow. I would just draw a line right here. So now I have a 5 by 4 rectangle. Area of a 5 by 4 rectangle is just 4 times 5. And then I have a triangle with a base of 8. See that 8? That distance from here to here, so that's the distance from here to here, so that's 8. And the height is the difference between 9, which is the distance from here to here, and 5. So 9 minus 5, of course, is 4. So I know that this triangle is an 8 by 4. So base times height divided by 2, or just take half of one of these numbers. I'm going to take half of 4. 2 times 8, of course. It's pretty simple. Then I would find that out, and then I would add it to the portion of the rectangle. We did actually in a Desmos activity almost this exact idea of Ashley's work and Tiana's work. Here is the work that 2 students did to find the area of the same parallelogram. So you can see that the parallelogram is shaped like this. And Ashley, she used this whole 10, the entire 10 units, as one of the dimensions. But that's not true. She used 3, which I think is the height of this parallelogram. I would agree with that. So she has some elements that she noted, right? See, the height is right here from the apex of the shape down to the base, so that's most definitely 3. But the base would be just this part, right? 1, 2, 3, 4. So it's a 4 by 3 parallelogram. 4 by 3. So it's the same, and this is the same, right? So it's still a 4 by 3. Tiana's work, hers a little different. Her mistake is a little different. And I think most of you can see it. She used a slant side as the height, which of course you can't do, right? It's going to artificially inflate the size of the shape, whatever the shape is, whether it's a triangle, parallelogram, trapezoid, whatever it might be. Okay? So go ahead and calculate the correct area of that and put that down here, and you'll be all set. This is going to be worth 20 points, approximately 2 points a question. And good luck. Hopefully this video helped a bit.